Welcome back, everybody. Today we're going to be looking at the equation of a circle lesson. Equation of a circle. Actually, for us, this is not Unit 9. This is different. Unit 8. Okay. So, what specifically about the equation for a circle? We need to cover a few subtopics here. We'll be going over the standard form of a circle. So, you need to know what that looks like and how to use it. Standard form of a circle. Also, the general form of a circle. So we're going to look at two different ways to write the equation of a circle. Also, we need to be able to go back and forward from standard to general and back and forward. Okay, so I want you to be able to see either version of a circle's equation and to be able to interpret how to draw it and how to go back and forward from one form to the other. These are our goals for today. In order to go from standard to general or vice versa, we need to review this concept from last year, completing the square. It's an algebra concept that we did while working with polynomials to go from expanded form of a polynomial back to the cleaner form. So it's that process. So we'll be looking at that today as well. It's review from last year. Here we go. Oh, before we get started, a reminder, if you're not taking notes on this, then it's not counting as attendance today. You must send me a picture either through email or upload it into Google Classroom, a picture of your notes to count as attendance. Okay? I'm going to be using this to tell your teachers if you tried the lesson or not. So you must take notes on what you're going to see coming up. Okay? Then when we're done, you should be armed and prepared to take the mastery test. Okay, thank you. Do a good job. I trust you. I know you're going to do great. Here we go. Okay, the standard form of a circle. So I'm just going to write it out here. X minus a squared plus y minus b, in parentheses again, squared, equals r squared. Now, what are these letters? Whatever the number for a and b is, that's the center of the circle. And r, not r squared, but r itself, notice the difference. In the equation, it's r squared, but the square root of whatever that number is that will be given, that is the radius of the circle. Remember, the radius is the distance from the center, which we have as AB, out to the edge of the circle in all directions. So here's an example with some numbers in it. Say we were given this, x minus 10 squared plus y minus 5 squared equals 4. If I was given this, I can quickly figure out what the center is. The center is a comma b. That's the number that's being subtracted from x and the number being subtracted from y. So what's being subtracted from x? 10. And from y, we see it's minus 5. So, oops, getting a little crazy. So the center is 10 comma 5. The radius, it's very, very easy to forget and to misinterpret the formula. The radius is not 4. The radius is the square root of whatever that number is on the right side. So the radius of our circle in this example is 2. Look at the formula above. It's the x parentheses squared plus the y parentheses squared is equal to the radius squared. So it's going to be often given to us as a larger, it's squared version of whatever the true radius is. So here's what this looks like. Since we know the center, 10, 5, and we know the radius is 2, then we should be able to draw a quick picture of this. Okay, so I eyeballed it. I'm making my x-axis 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. And then we want to go up 5, try to keep it the same units as we used below. 1, 2, 3, 4, 5. So at 10, 5, over 10, up 5, right here, assuming I'm at those right measures, there's my center. And the radius is 2 units. So that means 2 to the left, 2 down. Maybe my units are off. Looks like they are. 2 to the right, and then 2 above. Okay, so obviously my drawing is not very perfect, but hopefully you get the point. How we can make a quick sketch of our circle if we need to. It's 2 away in all directions. It's easy to draw the like go 2 down, 2 left, 2 up, and 2 right because we're on a graph, right? So it's usually good to make those ones and just connect the dots. So that's standard form of a circle. Now, here's a typical type of a question. We're given a graph of a circle. We need to write the equation of this circle in standard form. So here's the equation again. You should have it in your notes. So x minus a squared plus y minus b squared equals the radius squared. Okay, so we need to just fill in a, we need b, and we need the radius r. So what is the center of the circle? Can you see it? What is the direct middle of this circle given to us in the picture? It's right here, right? What is the coordinate? To the right 3, up 5. 3, 5 is A and B. So we're going to take 3, 5 and put them where they go in our standard form equation for a circle. X minus 3 squared plus y minus 5 squared. Okay, now we got to put in r. What's the radius? How far is it from our center, 3, 5, out to any of the edges we choose? Looks like it's 2 again. 2 to the right, 2 up. So we're going to put in 2 for r. And remember, that's 2 squared. It's radius squared always. So it's going to be equal to 4. So our final answer, x minus 3 squared. Y minus 5 squared equals 4. Let's try another one. Write the equation for this circle in standard form. Now, a quick word on taking notes for this. If you don't want to show the circle in your notes, that's fine, but I do expect to see you writing out your formula and then your final answer if there's any simplifying. So it's okay if you don't want to draw the picture I drew. That's okay. But I do expect to see you writing your answer down. All right, so we need to know the center. We need to know the radius. Go ahead and pause the video so you can practice this on your own before you see me do it. Okay, hopefully you've given it a shot or found the answer. You're ready to look at this. The center looks like it's here. I'm going to just guess that, and then I'm going to double check before I commit to it. I've got 3 to the left and 3 to the right, 3 up and 3 down. So I'm right in the middle. It's all the same number of units away from all the sides, 3. So here's my center. It's -2, 1. That's A and B. And I've already kind of said what the radius is too. It's 3 away on all sides. So therefore, we've got all the parts we need. So let's jump in. X minus A, right? What is A this time? -2? Don't forget, the formula itself starts out like X minus and Y minus. So if you've got a negative number in there, you're going to end up with a negative or minus a negative situation. You're going to end up with X plus. So the actual center of the circle is always the opposite, the A and B, of what it looks like in the formula. Okay, if this says X plus 2, that should be a clue that we are at the X negative territory. Okay, and continuing, Y minus B, so Y minus 1 squared equals the radius squared. So what's 3 squared? 9. There we go. Okay, next. A nice word problem. No picture given. What is the equation of a circle with center -3, -1 that contains the point 1, 2? So they're not telling us the radius. Interesting. They did tell us the center right here. So that's useful, right? We know A and we know B. And then what's up with this? They're not telling us the radius, but they're telling us that the circle has this point on its edge, 1, 2, 1, 2. Now, there's actually several ways I think we could go about solving this problem. Our issue at this point is really all we need to know is the radius. Let's start writing our answer. We know the center, so we can say X plus 3 squared plus Y plus 1 squared. Why am I writing X plus 3 and Y plus 1? Shouldn't those be minuses? When I plug in -3 and -1, the formula cancels those negatives and it becomes X plus and Y plus. But we don't know what radius is. So it's going to stay as R squared for now. We need to know what the radius is, and we would be done with this question. There's several ways we could do this. We can use the distance formula. Now, here's a quick sketch of why we can use the distance formula. The center is apparently -3, -1. So if this was my graph, over 3, up 1, there's my center of the circle. And it's also telling me that the point 1, 2 is involved here. It's on the circle. So over 1, up 2, right here. So we've got this point on the edge. We know this point's in the center. We could use our trusty distance formula to find the radius. Remember, distance formula gives you how long it is between two x's and two y's, which we have here. So that's one approach. I'm going to write that down. We could use distance formula, and that would tell you what the distance is between those 2 points, and therefore that's the radius in this case. I'm not going to do that though with you. We've had lots of practice recently with distance formula. I want to show you another way we can finish this question. Instead, look at the equation for the circle in standard form that we have so far. What are the variables in that equation? What are the unknowns, the letters without numbers? X, Y, and R, right? And we need R to be done. They also gave us a point on the circle, 1, 2. What does 1 comma 2 stand for again? What do those represent as far as their variables go? That's an x and a y. So therefore, if we take the equation of the circle so far and plug in 1 for x and 2 for y and simplify, it will lead us to r squared, and then we can take the square root and find r. So instead of using distance formula, folks, our strategy here, on the right, I'm going to write this down. It is to, instead of using distance formula, we're going to plug in 1 comma 2 for x and y, and then solve for r. Here we go. Plug in 1 and 2 for x and y. I'm working it out. I'm hoping you're doing the same thing at home. Go ahead and pause this video, work it out on your own, check your work against mine at the end. Hopefully I don't make a mistake today since we're not there to check each other. You're not there to check me. So go ahead and pause the video, work the rest of this out on your own, and then see what you get at the end. Compare that with my notes, okay? Okay, so hopefully you've tried it on your own now. Let's see what we get. Simplify the inside of those parentheses first. So 1 plus 3 is 4 squared. 2 plus 1 is 3 squared. And then it's equal to r squared still. Now do the squaring. 4 squared is 16. 3 squared is 9. Add those guys. 25 is r squared. We take the square root of both sides, and that gives you what r is. Remember, square root cancels squaring. So that's why we take the square root of something squared like this to find its square root. So now square root of 25 is 5. Therefore, the radius is 5. Woohoo! And now we can finish writing the proper equation. So down below here, we're going to go back and plug in the r. But of course, when we're writing a function equation, we want to leave the x and y blank. 5 squared, remember the formula is r squared. So we could write this more properly as equals 25. Let me do that. There we go. And there's our answer. We wrote the equation of the circle that has that center and contains the point 1, 2. This next question is just like the last one. So I want you to try it again on your own. Pause the video, try this question, and compare your work to mine. Okay, so again, we're going to go back to our standard form. Again, they're not telling us the radius. They're giving us the center point. And they're giving us some random point on the edge. It passes through -3, 2. So this can stand in for our x and y. We want to use those and the AB together in the formula to find radius. Let's go ahead and just cut to the chase and do that now. And then we'll write our answer at the end. So x minus a. So we're going to use -3 minus 5 squared. Y minus b, what is that? 2 minus -4. That's all going to be equal to the radius squared. Simplify the inside of your parentheses and then square what's ever left over. -3 minus 5. You're already down 3. You go down 5 more. What is that? -8. Okay, now for the next one, it's not the same thing that happened in -3, -5. That's not happening here. We have +2 minus -4. So this is where the negatives cancel, okay? Why is that? Because you're negating a negative thing minus a negative. So these turn into pluses here. So 2 plus 4 is 6. Okay, now negative 8 squared. If you're doing this in your calculator, you got to be careful because calculators don't always know if you're including the negative or not with the way you type it in. They're all a little different. So you have to remember that if you're multiplying a negative number times a negative number, what does that turn into? A positive number. So negative 8 times negative 8 is going to turn into positive 64. And then we've got 6 squared. That's a positive 36. Add these together and you should get 100. Take the square root of both sides and you get 10 is the radius. Now we can write the formula. I didn't start by writing the formula this time. I went ahead and started by just going right to the radius. We plugged in a, b, and x and y. So now to write the formula, x minus a, y minus b. So it's b is negative 4 already. So that's going to turn into y plus 4. Remember, the center is opposite of what it kind of looks like in those parentheses. Negative 5 and plus 4, or minus 5 plus 4. And then we found the radius. It's 10. So 10 squared is 100. And there's our formula. Now it's time to look at the other form, the general form of a circle. Okay, and at the bottom, a note. Almost every question in the mastery test is in general form. So I like to use the standard form, and honestly, most books and classes and teachers in the world are going to use standard form just like I taught you already. It's the more useful form, okay? But general form, for some reason, is used a lot in our mastery test. So I want you to be able to understand both and to be able to go back and forward. So now I want to look at the general form with you guys. And then we'll talk about how to go back and forward. So what is the general form? It's a lot busier looking. What are some things you notice? I'm hoping that you notice two things when we compare, at least two things. There's even more to notice, but at least two things really pop out to me when I compare this form of the circle with what we've been doing, x minus a squared plus y minus b squared equals r squared. When I look at this one, there's no parentheses. Um, there's no like x plus or minus a number in a parentheses, right? No y plus or minus a number in a parentheses. And then the other thing that's important here, guys, is that it's equal to 0. So if you see these things happening, no parentheses and equal to 0, then that should be your clue that we're working with the general form of the circle. All the stuff is there for us to put this into standard form, but we have to work backwards of multiplication. Before I show you this, just think back to the last semester with me. Let me get to some blank space here. Remember back in last semester when we were working with parabolas? Just going to make up an example. X plus 1 squared. We started with them in what we called standard form of a parabola. Think back to this. A times x squared plus bx plus c. This is coming back to you, hopefully. A, b, and c were really important numbers. And we learned throughout the course of the class how to go from standard form, ax squared plus bx plus c, into the factored form, x plus something squared. Remember, going back and forth this way? That's what's happening with our general and standard form of the circles as well. When we start off, sorry, I don't know why I made this equal to 5. Let's just look at this example with x plus 1 squared. So if we start like this with a parabola, how did we get to standard form? We basically just need to multiply the two parentheses together. So this means x plus 1 times x plus 1, right? Because x plus 1 squared means that same parentheses times itself. And then we are multiplying and distributing x times everything in the second parentheses, and then 1 times everything in the second parentheses. And when we do this, what do we get? X squared plus 2x plus 1. So here we have the factored form when it's in a parentheses squared, and then we have the standard form below. And this is for a parabola, not for a circle, but the same exact concept is happening for us with our circles now. Okay. So what we are looking at with this form of the equation, the general form, we've got our x squared, y squared, and then some number. This is a coefficient for c, d, and e. So these will be whole numbers. One of them times x, something times y, and then plus something, plus a number just with no x or y, all equals to 0. So what we need to do is be able to factor this crazy thing until we can get it into parenthesis with x squared, and then a parenthesis with y squared, and then the leftover number, that'll be our radius squared. That's the basic idea of what we're going to be doing. Okay, so to practice this with you, I want to just do an example. So please copy this general form of the circle down for me. And then what we're going to do is complete the square to put it into standard form, going from general to standard form. So we've got x squared plus y squared minus 6x minus 10y plus 30 equals 0. Okay, now it's a little crazy because we're working with x and y at the same time. So we're going to actually be completing the square twice, I believe. So here's what we're going to do. I want you to group together the x numbers and group together the y numbers. So we're going to rewrite what we've got. I'm going to move my minus 6x over to be with x squared because they're x's. We should group them together. I'm going to leave some space, and then I'm going to move my plus y squared, and that needs to be paired up with my minus 10y, so that will be there. And then what I'm going to do is make more space again, and I'm going to push my plus 30 over here to the far right and equals 0. So take a moment and look at what I've got. I've just grouped together my x's and grouped together my y's, and it's all meant to be the same line of math still, but I've left some space after x numbers and space after y numbers. Okay, so what we need to do now is we're going to examine what is the number that is, what is the coefficient for x, and at the same time we'll do it for the y's. What is the coefficient for y? So in this problem we have -6, and then for the y's we've got -10. And here's the directions. I'm going to write these down. For the x and y numbers, the plane x and plane y, so the -6 and the -10, we're going to cut them in half or divide it in half. And then we're going to square that result. Square the result. And I'm going to do that now. So I'm going to examine my -6 and my -10. And individually, we're going to cut those in half, meaning divide it in half, and then square the result. So -6 divided by 2, cut in half. What is that? -6 divided by 2 is -3. Square -3 for me. What is that? -3 times -3 is +9. I'm going to add a plus 9, and let me fill in some other stuff here. So far, all I'm doing is cutting in half -6, and then I squared that, and I am going to add that result, the plus 9, into my equation. And I'm also going to subtract out -9 over here on the far right where the 30 is. Okay? I know you're thinking this is probably insane. We're doing some weird procedure by cutting in half and squaring, and then we're putting it into our equation and subtracting it back out. But notice that if I added in plus 9 and I subtracted out -9, they cancel each other, right? Plus 9 minus 9. So technically, we're allowed to do this because I'm correcting it as we go. We're subtracting out 9 on the right. Okay, now we got to do the same thing with the -10 or the -10. So cut it in half. That's -5. Square that. It's plus 25. So we're going to add 25. And over on the right, we're going to minus 25 too. Okay, now what we're looking at is like the quadratic form, x squared minus 6x plus 9, and we've got a quadratic with y's, y squared minus 10y plus 25. And because of this weird procedure we did in the middle, the cutting in half and squaring, and then adding it in, what we've done is we've created perfect squares. That's the term for this. You hopefully remember that from last fall, perfect squares. We've forced it to be perfect squares based on what we had. So the 9 and the 25 weren't magical. We created those because of the -6 and the -10. We forced it to be a perfect square. So now if we were to factor x squared minus 6x plus 9, this factors using the perfect square shortcut to x minus 3 squared. Okay, now if you don't remember how to do that, I don't blame you. It's been a while. One way to do this, if you don't remember the shortcut, is simply to use the lists. Remember, we made lists of what numbers multiply to make a 9, but add to make a -6. And the only set that works is -3 and -3. And so what we've done is we've factored these three terms to become x minus 3 squared. We can do the same thing with our y's. The only two numbers that multiply to make a 25 but add to make a -10 is -5. This is not x though. This is y minus 5. There we go. Squared. And then after that, we've still got that -25, -9, and plus 30. So let's simplify that business. So -25 added to a -9, and then plus 30. And you get -4, hopefully. That's what I got. Okay, now it's looking more like standard form, right? We've got a number with x and a number with y and the parentheses squared. Let's add that 4 to both sides. And now it's positive on the other side. So we've got x minus 3 squared plus y minus 5 squared equals 4. And what's the radius here? What's the square root of 4? It's 2. So now we've been given an equation in general form at the very top in black. We've converted it by completing the square for the x's and the y's. And now we've got it in standard form, and we know the center is 3, 5, and the radius is 2. Let's do another one. Here we go. Go ahead and copy this down, and then we'll start converting it into standard form. Step 1 is group the x numbers and the y numbers together. Leave some space so you can put stuff in there as we go. So x's, now y's, so plus y squared minus 2y And then we're going to scoot over and do our plus 1. That's that single number plus 1 equals 0. And remember, this is meant to be one line of math. We're just kind of breaking it apart to give ourselves space. Now you examine the numbers that are the coefficients, the plus 4 and the minus 2. Here's where we have to do our completing the square. We're cutting that in half and squaring it and then adding that into the problem. So 4 divided by 2 is 2. And then squared is a 4 again. So this time we're going to add in 4, and then we have to minus 4 over by our 1. And now for the y's, negative 2 divided in half is negative 1. Squared negative 1 is a positive 1. So you're going to add a 1 and minus a 1. Remember, you have to, if we add in 4 and plus 1, we have to subtract them out as well. Otherwise, we're cheating, and we're doing something that doesn't logically make sense. We have to account for that adding of 4 by subtracting it out. Now, we're ready to put it into parenthesis form. So, frankly, you might have noticed that when you first divide the positive 4 and the negative 2 in half, that's the number that's going to go in the parentheses anyways. Okay? But I don't want you to forget about subtracting out the square of it on the right side over here. We have to minus 1 and minus 4. So x plus 2 squared. So what's going to go in the parentheses is always the square root of that number. Actually, no, not the square root, the half of that number. And then y minus 1. So what's going to go in the parentheses is always the coefficient 4 and negative 2, those numbers divided in half. That might be a little helpful to use as a shortcut. Okay, now we've got to simplify these 3 on the right and then move it over to the opposite side of the equal sign. So negative 1 and plus 1, we can just cancel those guys. So we're left with negative 4 again. We add 4 to both sides, and we're done. We have x plus 2 squared plus y minus 1 squared equals 4, or let's go ahead and say 2 squared for the radius squared. Okay, next, I've got another example, but I'm going to, I want to look at some problems from Edmentum with you quick. We won't do all of them, but we'll look at a few. A circle is described by the equation x squared plus y squared plus 14x plus 2y plus 14 equals 0. What are the coordinates for the center of the circle and the length of the radius? So they're just asking you to find a and b, and they're asking you to find r. And that's what we see on the left for our options. So this is the same problem that we have been working on already. We have to convert it to standard form and then be able to state the center and the radius. Let's give it a shot. So we group these guys together. X squared plus 14x plus y squared plus 2y equals 4. Oops, crap. Plus 14 equals 0. Okay, now divide 14 in half. That's 7. Square 7 plus 49. So I'm going to add 49 and I'm going to do a minus 49. Now for the y's, 2, cut it in half, that's 1. Square 1, that's plus 1. And I'll have to minus 1 as well. I'm going to put that right here. So all parts are accounted for. Okay, so for the x's, it's going to be in this form, x plus a number or x minus a number. So what do you get when you divided 14 in half? It's plus 7, right? So this is x plus 7 squared. And now looking at the y's, what do we get when we divide that 2 in half? 1. So it's y plus 1 squared. Now deal with the numbers. So negative 49 plus 14 minus 1. Okay, I got negative 36. So it's minus 36 equals 0. We move that over by adding 36 to both sides. There we go. Now it looks like here's our equation. So what is AB? Remember the formula is x minus y minus. So if this is plus 7 and plus 1, we're actually dealing with A is negative 7. It's always the opposite, remember? B is negative 1. So we would write it like negative 7, negative 1. I see two options there. Is the radius 36 or is the radius 6? What is it? Remember, the formula is r squared. So if this says 36, that is r squared. So the true radius is the square root of 36, 6. Next. What is the general form of the equation of the given circle with center A? Okay, this is actually the first time I've done this type of problem with you. They want us to state the general form, not the standard form. So it's important that you know the difference. We can write the standard form very fast from this. We have A, we have B, and 5 is R. So let's plug it in and see what we get for standard form. This is the first one we learned. I think it's the easier one. It's the more useful one too. So it's x minus negative 3. How are you going to simplify that? I hope you remember. X plus 3. X minus a negative, that turns into x plus. So we've got x plus 3 squared. And then the y's, it's y minus 12. That's y minus b squared equals r squared. So 5 squared. So how do we turn this into general? Sorry, I haven't taught this to you yet, but now we'll see it. All we got to do to turn it into general form is to multiply the stuff that says it's supposed to be squared. X plus 3 squared, that's the whole parentheses. That means it's x plus 3 times x plus 3. And then do the y's as well. Y minus 12 times y minus 12 equals 25. So there's a lot of distribution, so it'll be good practice for everybody. X times x, x squared. X times 3, that's plus 3x. Now for this 3 times x is another plus 3x. 3 times 3 is plus 9. Move on to the y's. Y times y, y squared. Y times negative 12 minus 12y. Negative 12 times y, negative 12y again. They'll always be doubles, okay? Just like you're seeing here, that'll happen each time. Negative 12 times negative 12 is a plus 144. Double check me. Okay, so yes, it's a lot of math, but a lot of this is going to simplify. So 3x plus 3x, that becomes 6x. I'm going to box the whole numbers, and we'll come back to those at the end. So plus 9, plus 144, and then on the far right, we've obviously got that 25. So let's box that as well. We'll deal with those at the end. Let's deal with the negative 12y minus 12y. So that's like saying negative 12 combined with negative 12, negative 24y. Done. Now we've got to deal with 9 plus 144. What is that? 153. Equals 25. And last step is to minus 25 from both sides. So 153, take away 25. 128. So all together here, and I'm going to move my x squared and y squared to be together just so it looks like general form. X squared plus y squared plus 6x minus 24y. Now remember, the order that you add things can change, and it doesn't change the sum. So that's why we're allowed to like move the order of these things. I'm not changing the sign, I'm just moving the order. X squared plus y squared plus 6x minus 24y um, plus 128 equals 0. Remember, in general form, it's going to be equal to 0 and no parentheses. We've eliminated those back at the beginning. So it started in standard form right here, and we ended at the bottom in general form. Now, I guess it's not necessarily easy what we just did here, but I think it is a little more conceptually easy to just multiply our parentheses together and simplify like terms um, than it is to go from general to standard where we have to complete the square. All right, we'll do one more and then I'm going to stop. And then I want you to send me your notes, please, and give it a shot doing the mastery test yourself. What is the general form of the equation for this given circle? Okay, so this is honestly the same kind of question we just did, except they're not telling us A and B right off the bat, are they? They're telling us instead 2 points on the outside. Okay, so I think we can use some just logic and reason to work backwards here and find A and B. Point A is 4 to the right and 7 high. So what's directly below point A? Well, our center is directly below. So if this is a height of 7, the height for the center has changed. Did the x of the center change? No, it's directly below. So the x coordinate, or rather the A and the B here, the A is going to be 4. It's directly below that top point, point A. Now, what about the big point B, 7 comma 4? We know the height of that. This height is 4, right? The y coordinate is 4. So that means our center has to be 4 also. So with a little detective work, we could figure out that the A and B is 4 comma 4. How about the radius? How far is it from here to here? I know it's not on like a proper graph, but if we have these points that we have, we should be able to subtract and find the radius. Actually, we could do it with the vertical one or the horizontal one. Look at the x numbers. The center is at 4, and it goes to 7. 4 to 7. How much space is there from 4 to 7? 3. So with a little detective work, we've found our A and our B and our radius. And again, they want us to write the general form. Oops. Okay. So we're going to do the same thing we did in the last few problems. We're going to write it in standard. We're going to simplify it by multiplying out our parentheses. So x minus 4 squared plus y minus 4 squared equals radius squared, 9. Start multiplying. So x minus 4 times x minus 4. I guess we should think of it as expanding. We're expanding out the exponents and multiplying. Yeah, and y minus 4 times y minus 4. Oops, no, squaring's done. We did that. Okay, so now the multiplying out. So x squared minus 4x minus 4x plus 16. Y's. Y squared minus 4y minus 4y plus 16 equals 9. And now we're going to combine these two and these two. So x squared minus 8x plus 16 plus y squared minus 8y plus 16. And now we need to subtract the 16 from both sides twice because there's just so happens there's two 16s here. So those cancel. And what do we got? I'm going to move my y over, or my y squared, so it looks like a general form. And then on the right, we've got 9 minus 16 minus... Oh, my bad. That was dumb. Hang on a second. I don't want to have it equal to a number. We want to have it equal to 0, don't we? So if I do this, 9 minus 16, that comes out to minus 23. But of course, we want it equal to 0, so I'm going to put that back on the left side like I'm supposed to. So here's our answer. Plus 23 equals 0. Okay, I didn't look at a clock, so I'm not sure how long this video is. So I'm going to stop. Remember, everybody, you need to send me your notes for basically this whole lesson. I'd like to see all of it, all the examples and the definitions of the formulas and everything. I want you to use those notes on your test. Do your mastery test. Send me your notes. Have a terrific day. I will be back tomorrow on Wednesday, so thank you for your hard work. I'll see you tomorrow. Bye-bye.